March 7, 1944. A German airfield near Aachen, occupied France. Luftwaffe personnel hear the distinctive sound of an American radial engine, low, powerful, unmistakable. They expect a strafing attack. Instead, they witness something extraordinary: an American P-47 Thunderbolt, wheels down, making a perfect landing approach. The massive fighter touches down smoothly on the German runway. Guards rush toward the aircraft, weapons ready, expecting a trick or sabotage attempt. The canopy opens. An American pilot climbs out, hands raised, clearly surrendering. The plane is intact, completely undamaged, fully fueled, armed with 8.50 caliber machine guns and carrying ammunition. Within hours, the P-47 is surrounded by Luftwaffe intelligence officers, mechanics, and engineers. This isn't just a downed enemy aircraft salvaged from a crash site. This is a fully operational American fighter, landed voluntarily, in perfect condition, an intelligence windfall. The aircraft is immediately classified top secret and transported to Rechlin, the Luftwaffe's primary testing facility. There, one of Germany's most experienced test pilots, Hauptmann Hans Werner Lurk, receives an assignment that will shake his understanding of American aviation: fly this captured P-47 and provide a complete tactical evaluation. What Lurk discovers, and what he writes in his official report, will shock Luftwaffe command and reveal truths about American aircraft that German leadership desperately didn't want to hear. This is that story. Before understanding Lurk's shock, understand what the P-47 Thunderbolt represented in 1944. The P-47 was the heaviest single-engine fighter of World War II, empty weight, 10,000 pounds, more than twice most fighters. Maximum takeoff weight, 17,500 pounds fully loaded. This was less a fighter and more a flying tank. It was powered by the Pratt & Whitney R-2800 Double Wasp, 2,000 horsepower radial engine, one of the most powerful piston engines ever built. 18 cylinders arranged in 2 rows. Supercharged for high-altitude performance. The armament was devastating: 8.50 caliber M2 Browning machine guns, 4 in each wing. 3,400 rounds of ammunition total. Combined firepower of 100+ rounds per second. Could carry bombs, rockets, and external fuel tanks. German intelligence knew these specifications from studying wreckage and captured documents. But specifications don't reveal how an aircraft actually performs. The P-47's design philosophy was pure American: overwhelming power, rugged construction, pilot survivability. It prioritized armor protection for the pilot, thick armor plating front and rear. Self-sealing fuel tanks that wouldn't explode when hit. Redundant systems: if one failed, backups existed. Raw power over finesse: the massive engine compensated for heavy weight. This contrasted sharply with German design philosophy, which emphasized lightweight and maneuverability. Precision engineering and efficiency. Minimizing armor to maximize performance. The P-47 represented a different way of thinking about air combat, one the Luftwaffe was about to study intimately. The man chosen to evaluate the captured P-47 was exceptionally qualified. Hauptmann Hans Werner Lurk was one of the Luftwaffe's most experienced test pilots, over 2,000 flight hours in dozens of different aircraft types. Combat experience as a fighter pilot before becoming a test pilot. Engineering background: he understood aircraft design, not just flying. Fluent in English, which helped him understand American technical documents. His role at Rechlin was evaluating captured Allied aircraft through a program called Circus Rosarius, the Circus of Enemy Planes. Lurk had flown captured British Spitfires, American P-38 Lightnings, P-51 Mustangs, and Soviet aircraft. He'd written detailed tactical evaluations comparing them to German fighters. His reports were respected for their honesty and technical accuracy. He didn't sugarcoat bad news or exaggerate German superiority. When Lurk received the P-47 assignment, he approached it scientifically: study all available intelligence on the aircraft. Interview the captured pilot about operational procedures. Conduct ground testing of all systems. Perform flight testing across the performance envelope. Compare directly against German fighters. Write a comprehensive tactical report. Lurk expected to find the P-47 inferior to German fighters in most respects. The aircraft was clearly heavy and seemed unsuited to the dogfighting style that dominated European air combat. German fighters like the Bf-109 and Fw-190 were lighter, more maneuverable, and built for close-range turning combat. How could this American behemoth compete? He was about to find out, and his assumptions would be shattered. Lurk's first exposure to the P-47 was climbing into the cockpit. His initial impressions, recorded in his report, reveal his surprise: size and space. The cockpit is enormous compared to German fighters. I can move freely, stretch my legs, adjust my position. German cockpits are cramped, you're wedged in tightly. This is like sitting in a comfortable room. Visibility: the canopy provides exceptional all-around vision. The bubble canopy design lets me see in every direction with minimal obstruction. Our fighters have significant blind spots. This doesn't. Instrumentation: American instruments are straightforward and well organized. Everything is clearly labeled in English, but the logic is obvious. Controls are logically positioned and color-coded. Build quality: the construction is crude by German standards, heavy, over-engineered, with large tolerances. But everything is robust. Nothing feels delicate or fragile. You sense this aircraft was built to survive combat damage. Comfort features: the Americans included features we consider luxuries: adjustable rudder pedals, comfortable seat with armor protection, heating system that actually works. German designers prioritize weight savings. Americans prioritize pilot comfort. These observations already challenged Lurk's preconceptions. German design emphasized minimalism and efficiency. American design emphasized durability and operator comfort. Which philosophy was better? Lurk would soon find out when he started the engine and experienced the P-47's overwhelming power. Starting the P-47's R-2800 engine was Lurk's first shock. The engine start procedure is simple, too simple by German standards. Prime the engine, engage the starter, and this massive radio roars to life. The sound is incredible, deep, powerful, unmistakable. German inline engines are smoother, more refined. This engine announces its presence violently. The vibration at idle is significant. The entire aircraft shakes. But when you advance the throttle, the power is astonishing. 2,000 horsepower is more than any German fighter engine. You feel it in your chest, the raw force available. Taxiing this aircraft is initially awkward. It's nose-heavy due to the large radial engine. Forward visibility on the ground is poor, you must taxi in S-curves to see ahead. But the controls are light and responsive for such a heavy aircraft. Lurk's technical analysis noted critical differences: German engines, Daimler-Benz DB605, BMW 801, produced 1,400 to 1,700 horsepower, adequate but not overwhelming. The R2800's additional 300 to 400 horsepower gave the P-47 performance options German fighters lacked. Reliability: the engine runs roughly but consistently. It doesn't require the careful management our engines demand. You can abuse this engine: rapid throttle changes, sustained high power, and it keeps running. Fuel consumption: this engine drinks fuel at an alarming rate. But the Americans compensated with enormous fuel capacity, 305 gallons internal, plus external tanks. Range exceeds our fighters despite the consumption. The realization was forming: American engineers accepted weight and complexity to achieve overwhelming reliability and power. Would this trade-off work in combat? Lurk's first takeoff in the P-47 shattered his expectations. I advanced the throttle expecting a long takeoff roll due to the weight. The acceleration was shocking. This aircraft weighs twice what our fighters weigh but accelerates faster than anything I've flown. The power-to-weight ratio is extraordinary. The aircraft became airborne after approximately 600 meters, shorter than a Bf-109 despite weighing twice as much. The climb rate is exceptional. I achieved 3,000 feet per minute at full power. Our fighters achieve 2,500 to 2,800 fpm at best. The torque from the massive engine requires constant rudder correction during climbs. But once trimmed, the aircraft is stable and easy to fly. The controls are surprisingly light, hydraulically boosted in ways our fighters aren't. His report includes detailed performance measurements: sea level speed, 360 miles per hour, comparable to FW-190. Climb to 20,000 feet, 9 minutes, faster than any German fighter. Maximum speed at altitude, 440 plus mph at 30,000 feet, exceptional. Service ceiling, 42,000 plus feet, far higher than German fighters could operate effectively. These numbers stunned Lurk. On paper, the P-47 seemed like a heavy, sluggish aircraft. In reality, it outperformed German fighters in nearly every measurable category except turn radius. The question was, why? Lurk's analysis: the Americans compensated for weight with excessive power. The result is an aircraft that performs better than it should based on traditional design principles. This is inefficient but effective, a very American solution. As Lurk climbed the P-47 to altitude, he discovered the aircraft's true purpose. Above 25,000 feet, this aircraft transforms. The turbo-supercharger maintains engine power at altitudes where our fighters suffer significant power loss. German fighters at 30,000 feet are gasping for air. The P-47 performs as if at sea level. At 35,000 feet, I'm still climbing with power to spare. Our fighters cannot effectively operate at this altitude. The Bf-109 can reach these heights but has no combat capability there. It wallows, controls are mushy, and power is minimal. The P-47 is still responsive and powerful. This was a critical tactical revelation. The P-47 owned the high-altitude battlefield. German bombers typically operated at 20,000 to 25,000 feet. The P-47 could loiter above them and dive to attack from positions German escort fighters couldn't reach. I conducted simulated attacks from 35,000 feet, diving to 25,000 feet. The acceleration in the dive is terrifying. This aircraft becomes a meteor, speed builds rapidly to 550 plus mph. Nothing we have can dive this fast. The aircraft remains stable and controllable even at these extreme speeds. The implications were clear: American bomber formations are escorted by fighters that can attack from altitudes we cannot defend. They dive to attack, then climb back to safety faster than we can pursue. This is a fundamental tactical advantage. Lurk's report included a devastating conclusion: if the enemy chooses to fight at high altitude, we cannot effectively contest them. The P-47's performance above 25,000 feet exceeds our capabilities entirely. Lurk's dive tests revealed the P-47's most shocking characteristic: I initiated a dive from 35,000 feet, pulling 2.5 g to establish a 45-degree dive angle. The aircraft accelerated violently. Within seconds, the airspeed indicator showed 500 miles per hour. At 550 miles per hour, I was exceeding anything I'd experienced in German aircraft. The P-47 continued accelerating. At 575 miles per hour, beyond the limits of our fighters, the P-47 remained stable. The controls were heavy but responsive. There was no buffeting, no structural stress indicators, no loss of control. This aircraft was designed for these speeds. I pulled out of the dive at 15,000 feet, sustaining 5 g. The airframe handled it without complaint. The wings flexed but showed no signs of structural damage. This is built like a tank that flies. The tactical implications stunned Lurk. In combat, if a P-47 dives away from German fighters, we cannot follow. Our maximum safe dive speed is approximately 450 to 470 miles per hour. Beyond that, we risk structural failure or compressibility issues that make recovery impossible. The P-47 can dive to 575 plus mph and pull out safely. This means, the P-47 pilot controls the engagement. If he wants to fight, he fights. If he wants to disengage, he dives, and we cannot follow. This is a decisive advantage. Lurk tested German fighters against the P-47 in simulated combat, Bf-109G Dove after the P-47. At 480 miles per hour, the Bf-109's controls locked up due to compressibility. Recovery was dangerous and slow. The P-47 escaped easily. FW-190 performed better but still couldn't match P-47 dive performance. Conclusion: the P-47 is effectively invulnerable to pursuit in a dive. This is devastating. Lurk conducted live-fire tests against ground targets to evaluate the P-47's armament. The Americans armed this aircraft with 8.50 caliber machine guns, 4,800 rounds per minute combined fire rate. I engaged a target from 500 meters. The result was obliteration. Nothing survived. The target, simulating an aircraft, was shredded completely within 2 seconds of firing. Our fighters typically carry two 20mm cannon and two rifle-caliber machine guns, or three 20mm cannon. The total firepower is less than the P-47's 8.50s. But more importantly, the American approach offers advantages we hadn't considered. Ammunition capacity: the P-47 carries 3,400 rounds of .50 caliber. This allows 30-plus seconds of continuous firing. Our fighters carry ammunition for 15 to 20 seconds maximum. In combat, this means the P-47 pilot can engage multiple targets or make multiple firing passes. We must make every burst count. Reliability: the American machine guns fire flawlessly. No jams, no malfunctions. Our 20mm cannon are powerful but prone to stoppages, especially in cold or high-G maneuvers. The .50 caliber M2 Browning simply works. Ballistics: 8 guns concentrated in the wings create a cone of fire that's difficult to avoid. The flat trajectory of the .50 caliber makes aiming easier than our cannon at range. At 400 meters, I could hit targets reliably without complex lead calculations. Lurk's tactical assessment: while individual .50 caliber rounds are less destructive than 20mm shells, the volume of fire and reliability create lethality that may exceed our cannon-armed fighters. The P-47 can sustain fire in combat situations where our weapons would fail or run out of ammunition. Lurk examined the P-47's construction and armor protection with German engineers. This aircraft is over-engineered by our standards. Where German fighters use minimal structure optimized for strength-to-weight ratio, the P-47 uses massive structural members, thick skin, and redundant systems. It's wasteful, and brilliant. The armor protection shocked them. The pilot sits behind 1.5-inch armor plate, thick enough to stop 20mm cannon shells from behind. The windscreen is 2-inch bulletproof glass. Additional armor protects engine, oil system, and fuel tanks from frontal attacks. Total armor weight, approximately 350 pounds. We'd never add this much armor, it's nearly the weight of our entire fuel load. But it makes the pilot nearly invulnerable to fighter attacks from behind. I discussed this with engineers. They calculated that a P-47 hit from behind by our standard fighter armament, 2 MG, 131 13mm machine guns and 2 MG, 151 20mm cannon, would likely protect the pilot completely. The armor absorbs everything except lucky hits to engine or control surfaces. Self-sealing fuel tanks: the Americans developed fuel tanks lined with rubber compounds that seal bullet holes automatically. When hit, the tank self-heals before significant fuel is lost. Our tanks simply leak until they're empty or explode. This technology alone dramatically increases survivability. Redundant systems. The P-47 has backup systems for critical functions. Dual ignition on the engine. Manual backup for hydraulics. Alternative control methods if primary systems fail. Our fighters become unflyable if key systems are damaged. The P-47 limps home. Lurk's conclusion: this aircraft was designed assuming it will be hit. German fighters are designed assuming they won't be hit. In combat, the American assumption is more realistic. Lurk expected the heavy P-47 to handle like a truck in turning combat. He was wrong. I conducted turning tests against simulated enemy fighters. The P-47 cannot sustain turns with lightweight German fighters. A Bf-109 will outturn it in sustained combat. But the P-47 has other advantages. Initial turn rate. The P-47's hydraulically boosted controls allow the pilot to pull harder immediately. The initial turn rate, the first 90 to 180 degrees, is competitive with our fighters. The aircraft bleeds energy quickly in sustained turns, but that initial turn is often what matters in combat. Roll rate. The roll rate is exceptional. This surprised me completely. The P-47 rolls faster than the Bf-109 at speeds above 300 miles per hour. The reason: hydraulically boosted ailerons that remain light at high speeds. Our fighters have heavy controls at high speeds. The P-47's controls are consistent. Energy retention in dives and zoom climbs. The weight and power combination creates extraordinary energy characteristics. The P-47 accelerates in dives and retains speed better than our fighters. In boom and zoom tactics, dive, attack, climb away, the P-47 is superior to anything we have. Lurk developed tactical conclusions: the P-47 cannot dogfight German fighters in sustained turning combat. But American pilots shouldn't dogfight. Their aircraft is designed for different tactics. 1. Attack from altitude using speed advantage. 2. Make 1 or 2 firing passes. 3. If the enemy survives, extend away using superior dive speed. 4. Climb back to altitude using superior climb rate. 5. Repeat. Against these tactics, we have no effective counter. We cannot climb to their altitude. We cannot dive after them. We cannot escape their attacks. The P-47 dictates combat terms completely. Lurk's long-duration flights revealed another American advantage: the P-47 carries 305 gallons of internal fuel, nearly double our fighters' capacity. With external drop tanks, total fuel load exceeds 500 gallons. This creates range capabilities we cannot match. Typical mission profiles: a P-47 can fly from England to Berlin and return, approximately 1,100 miles round trip. Our fighters barely reach 400 miles combat radius. This means American fighters can escort bombers deep into Germany. We cannot defend our interior. Loiter time: with external tanks, the P-47 can remain over target area for 45+ minutes after flying 400 miles. This allows them to wait for our fighters to engage, then attack when we're low on fuel. We must land to refuel. They continue fighting. Flexibility: the range allows American pilots to avoid unfavorable combat. If they encounter superior numbers or disadvantageous situations, they simply fly somewhere else. We cannot pursue due to fuel limitations. They control when and where combat occurs. Lurk's strategic analysis was devastating. The combination of high-altitude performance, dive speed, and range creates a fighter that is strategically untouchable. We can occasionally shoot down individual P-47s through tactical skill or luck. But we cannot prevent them from escorting bombers anywhere in Germany. We cannot deny them air superiority. This is a fundamental defeat. Our fighters were designed for short-range interception of bombers over German territory. The P-47 was designed to control airspace anywhere it chooses. These are fundamentally different missions, and the American approach is superior for strategic air warfare. After extensive testing, Lurk submitted his official evaluation. His conclusions shocked Luftwaffe command. Tactical assessment: the P-47 Thunderbolt represents a fighter design philosophy fundamentally different from German practice. While our fighters optimize for performance efficiency and agility, the P-47 optimizes for pilot survivability, operational flexibility, and strategic effectiveness. Performance superiority: in high-altitude performance, dive speed, climb rate, and range, the P-47 exceeds all German fighters by significant margins. Only in sustained turning combat and possibly acceleration at low altitude do our fighters retain advantages. Tactical implications: an experienced P-47 pilot using proper tactics is nearly impossible to defeat in our current fighters. He controls engagement terms completely. He can attack from untouchable altitudes, dive away at speeds we cannot match, and return to altitude before we can respond. If our pilot is skilled and lucky, he might achieve a kill. But probability favors the American. Strategic consequences: the introduction of the P-47 in numbers renders our current fighter force inadequate for defending German airspace against escorted bomber formations. We can no longer prevent American air operations over Germany through fighter opposition alone. Recommendations: immediate development of fighters capable of high-altitude performance comparable to P-47. Enhanced armament to defeat P-47 armor protection. New tactics emphasizing attacks on vulnerable areas rather than traditional dogfighting. Most importantly, recognition that we are facing an opponent with technological and industrial advantages we cannot match on equal terms. Lurk's report was not well received by Luftwaffe leadership. Göring's response, reported by witnesses: this is defeatist nonsense. German fighters are superior to American trash. Your test pilot is incompetent or compromised. I want him investigated. Other high-ranking officers dismissed the findings. Lurk has been fooled by one exceptional aircraft. Most P-47s won't perform this well. The American pilot who landed this aircraft probably sabotaged it before surrendering. The test results are invalid. Our pilots report shooting down P-47s regularly. How can they be invincible if we're shooting them down? The cognitive dissonance was understandable. German leadership had built their careers on the superiority of German engineering and design. Accepting that American brute force engineering produced superior results was psychologically impossible. The propaganda machine had convinced the public, and leadership themselves, that German quality exceeded Allied quantity. Lurk's report threatened this narrative. Some Luftwaffe officers did take the report seriously. Adolf Galland, General of Fighters, had combat experience with P-47s. He supported Lurk's conclusions and pushed for fighter development programs. Several test pilots who flew the P-47 after Lurk confirmed his findings independently. Experienced combat pilots recognized the tactical descriptions as accurate. But institutional resistance prevented meaningful response. Resources were diverted to jet fighter development, Me-262, rather than improved piston fighters. Tactical training didn't change. Pilots continued using dogfighting tactics ineffective against P-47s. Production priorities remained focused on fighters designed for obsolete tactical requirements. Lurk's report, though accurate and potentially war-changing if acted upon, was largely ignored. Understanding why Lurk's accurate assessment was dismissed requires understanding Nazi military culture, technological chauvinism. German leadership genuinely believed German engineering was inherently superior to Allied engineering. This wasn't just propaganda, it was ideological conviction. The idea that American mass production could create superior weapons was incompatible with Nazi racial and cultural theories. Economic denial. By 1944, Germany's industrial capacity was strained. Developing new fighters to counter the P-47 would require resources Germany didn't have. Rather than admit this, leadership denied the problem existed. Hitler's interference. Hitler personally involved himself in aircraft development, often making decisions based on ideology rather than tactical reality. He prioritized bombers and ground attack aircraft over fighters, believing offensive capability mattered more than defense. Institutional inertia. the Luftwaffe had trained pilots, developed tactics, and built an entire system around existing fighters. Admitting those fighters were inadequate meant admitting the system was failing. This was organizationally impossible. Selective evidence. While Lurk's report showed P-47 superiority, individual combat reports showed German pilots occasionally shooting down P-47s. Leadership focused on successes and ignored the overall statistical picture. The result was strategic failure. Germany continued producing fighters that couldn't effectively counter American aircraft. Pilot training emphasized tactics that didn't work against P-47s. Resources were wasted on programs that didn't address the actual threat. The opportunity to respond to Lurk's warnings was squandered through institutional denial and ideological blindness. Interestingly, American military leadership understood the P-47 strengths even before Lurk's report confirmed them. The P-47 was designed based on combat lessons from British experience fighting Germany in 1940 to 1941. British pilots learned that German fighters couldn't be outturned by heavier aircraft. But they could be outclimbed, outdived, and outranged. The P-47 incorporated these lessons: massive engine for superior climb rate, rugged construction for dive performance exceeding German fighters, enormous fuel capacity for strategic range, heavy armament and armor for survivability. American tactical doctrine for the P-47 emphasized: never dogfight German fighters in sustained turns. Use altitude advantage to attack, dive away, climb back. Control engagement terms. Force the enemy to fight your way or not at all. Training films showed P-47 pilots exactly how to exploit their advantages and avoid German fighters' strengths. Combat results validated the design. By mid-1944, P-47s were achieving kill ratios of 4-to-1 or better against German fighters, for German fighters destroyed for each P-47 lost. P-47 loss rates from combat damage were lower than other American fighters because armor and durability allowed damaged aircraft to return home. P-47 successfully escorted bombers deep into Germany, accomplishing the strategic mission they were designed for. American designers didn't stumble into success. They deliberately engineered an aircraft that exploited German weaknesses and rendered German strengths irrelevant. Lurk's report confirmed what American designers already knew: their approach worked. The P-47 versus German fighters illustrated fundamental design philosophy differences. German approach: minimize weight for maximum agility. Optimize every component for efficiency. Precision engineering with tight tolerances. Pilot skill and aircraft performance win combat. Accept vulnerability to achieve performance. American approach: use power to compensate for weight. Over-engineer for reliability and durability. Rough construction with large tolerances. Pilot survivability and tactical flexibility win combat. Accept inefficiency to achieve results. Neither approach was inherently wrong. German fighters were beautiful, efficient, and deadly in the hands of skilled pilots. They won countless dogfights through superior maneuverability and pilot training. American fighters were crude, heavy, and seemingly wasteful. But they won the war through superior durability, range, and tactical flexibility. The key difference: sustainability and scalability. German approach required highly skilled pilots, training took years. Precision manufacturing, limited production capacity. Perfect maintenance, difficult under combat conditions. Ideal combat conditions: close range, clear weather, favorable tactical situation. American approach allowed adequate pilot skill sufficient, training in months. Mass production, unlimited manufacturing capacity. Rough maintenance, aircraft tolerated abuse. Any combat conditions, aircraft performed across all scenarios. In a long war of attrition, American approach proved superior not because it was better engineering, but because it was better suited to industrial total war. Lurk recognized this in his report: the P-47 is not a better aircraft than our fighters in the traditional sense. It is a different category of weapon designed for different warfare. And for strategic air combat in 1944, their approach is superior to ours. What if Luftwaffe leadership had accepted Lurk's findings and acted on them? Possible responses: develop high-altitude fighters. The Ta-152H, developed later in the war, could match P-47 altitude performance. If prioritized in 1944 based on Lurk's report, it might have contested American high-altitude dominance. Change tactics: train pilots in boom-and-zoom attacks from above rather than turning dogfights. Use altitude advantage to offset the P-47's superior climb rate. Focus on attacking bombers rather than escorts, the actual strategic threat. Improve armament: develop weapons capable of penetrating P-47 armor. The -108 Malawian Quach's 30mm cannon could destroy a P-47 with one hit, but it wasn't prioritized until late in the war. Enhance existing fighters: add armor and self-sealing tanks to German fighters, accepting weight penalty for better survivability. This would reduce performance but increase combat effectiveness through better pilot survival. None of these responses happened because resources were committed to other programs. Leadership denied the problem existed. Ideological commitment to existing approaches prevented adaptation. By the time the threat was undeniable, Germany lacked resources to respond effectively. The tragedy is that Lurk provided accurate intelligence that, if acted upon, might have improved Germany's defensive capabilities. Instead, the report was filed away and forgotten. The lessons weren't learned until after the war, too late to matter. After the war, Hans Werner Lurk's wartime reports became available to aviation historians and engineers. His P-47 evaluation was recognized as exceptionally accurate. Every performance claim was verified by post-war American testing. Tactically insightful, his tactical assessments matched American doctrine and combat results perfectly. Professionally honest, unlike many German wartime reports that exaggerated German capabilities, Lurk reported uncomfortable truths accurately. Lurk survived the war and worked in aviation afterward. He consulted for aircraft manufacturers. He wrote extensively about his experiences testing captured Allied aircraft. He gave interviews emphasizing that German leadership's refusal to accept accurate intelligence contributed to defeat. His message was consistent: we weren't defeated by superior courage or numbers alone. We were defeated by superior design philosophy that we refused to acknowledge. I reported what I found. Leadership chose not to believe it. Modern aviation engineers studying the P-47 recognize what Lurk saw in 1944. The P-47 represented a paradigm shift in fighter design. Rather than optimizing for a single performance metric, it optimized for overall combat effectiveness. Rather than assuming ideal conditions, it assumed worst-case scenarios and designed for survival and adaptability. Rather than relying on pilot skill alone, it gave pilots tools that multiplied their effectiveness. This approach influenced post-war fighter design. American jets like the F-86 Sabre continued the philosophy: power, durability, pilot-friendly design. Soviet designers initially followed German lightweight approach but gradually adopted American emphasis on durability. Modern fighters universally incorporate the lessons: survivability, redundancy, and pilot-focused design matter as much as raw performance. Lurk's report wasn't just about one aircraft. It documented a fundamental shift in military aviation philosophy, one that shaped the jet age and beyond. Hans Werner Lurk's most shocking statements about the captured P-47 weren't technical specifications or performance numbers. They were his conclusions about what the aircraft represented. The P-47 Thunderbolt is not simply an enemy fighter. It is evidence that American industrial and engineering approaches have evolved beyond our understanding. We assumed mass production meant inferior quality. The P-47 proves that mass production can create superior capability through different design priorities. Our fighters are masterpieces of engineering efficiency. The P-47 is a masterpiece of combat effectiveness. These are not the same thing. We optimized for the wrong goal. I flew this aircraft expecting to find weaknesses we could exploit. Instead, I found an aircraft that renders our tactical approach obsolete. The deficiency is not in our pilots' courage or skill. It is in our fundamental understanding of what a fighter should be. The Americans designed an aircraft assuming their pilots are not supermen, their maintenance is imperfect, their tactics are straightforward, and combat is chaotic. They built a weapon that performs excellently under real-world conditions rather than ideal conditions. This is wisdom we lack. Most shocking, this aircraft proves that industrial capacity is a weapon as deadly as any gun or bomb. The Americans can afford to build fighters that weigh twice what ours weigh, use twice the fuel, require twice the maintenance, because they have the industrial capacity to support such inefficiency. This industrial advantage may be insurmountable. These words shocked because they acknowledged truths Nazi ideology denied. American engineering was sophisticated, not crude. Industrial mass production was an advantage, not a weakness. German fighter design was optimized for the wrong war. The conflict couldn't be won through superior individual weapons alone. Lurk's honest assessment threatened the foundational myths of Nazi military superiority. That's why his report was buried. But history vindicated him. The P-47 and aircraft like it proved that American approaches to military aviation were not just different from German approaches, they were better suited to total industrial warfare. The Luftwaffe test pilot's shocking words were shocking because they were true. And truth, in 1944 Nazi Germany, was the most dangerous thing of all.